Okay. So once again, very good afternoon to all of you who are here. So we are discussing the general organic chemistry part, right? So yesterday I have given one homework for you guys. Do you all remember that? Has anyone done the homework? So this was the question, right? So this is assignment or the homework I gave you yesterday. So we are discussing about the IUPAC nomenclature of the compounds which are open chain, and we have also came across the compounds which has one functional group and more than one functional group, etc. Right? So from that I gave this question as a homework, and this question has four subdivisions. Did you guys complete the homework? Can anyone tell me the name of the first compound? Can anyone tell me the name of the first compound? Did you guys do the homework or not? What is the name of the first compound, students? The IUPAC name of the first compound. So which is the longest chain? The straight chain, right? So how to number from left to right? So it is 1, 2, 3, 4, 5, 6, and 7. So we have two substituents. One is chloro and the other one is bromo. So both are attached to the same carbon. So in that case, we have to go according to the alphabetical order, right? So the name of the compound will be 3-bromo, 3-chloro, heptane. 3-bromo, 3-chloro, heptane. So we have 7 carbons in the straight chain, right? So it is 3-bromo, 3-chloro, heptane. Okay. Now coming to the second compound. So in the second compound, we have CN group. So CN is the functional group. Name of the functional group is nitrile. We have only one functional group. If we are having only one functional group, then we have to use the suffix. So the suffix for CN is nitrile. Okay. So now check for the other substituent. The other substituent is methyl. So here we have another substituent which is methyl. So we have one carbon, right? So this is methyl. So now you have to number the carbon atoms in the parent chain. So parent chain is the straight chain. I have to start the numbering from CN carbon, okay? So carbon number 1, 2, 3, 4, and 5. Okay. So carbon number 3 has methyl attached to it. So it is 3-methyl pentane nitrile. 3-methyl pentane nitrile. Okay. Now coming to the third one. So in the third compound, I have one functional group and one substituent. So who is that functional group? C double bond OH. So what is the name of this functional group? This is an aldehyde, right? This is an aldehyde. So now I have to start numbering the aldehyde carbon. So 1, 2, 3. So to the third carbon, chloro is attached. So it is 3-chloro-propanal. 3-chloro-propanal. It is an aldehyde, right? So it is 3-chloro, and the straight chain has, the parent chain has 3 carbons. So it is 3-chloro-propanal. Okay. So can anyone try the name of the fourth compound? Can anyone try the name of the fourth compound? So let me expand the structure of the fourth compound. So we have CH. CH is attached to 2-chlorine. And we have CH2, which is attached with OH. So OH is the functional group. Cl are the substituents. Okay. So functional group attached carbon should get number 1, and the next one is number 2. So now start from the substituent. So we have to start naming the substituents, right? So it is 2, 2 dichloro ethanol. 2,2 dichloroethanol. Clear? Do you guys have any doubt from this? 2,2 dichloroethanol. So I have asked you guys to do this as a homework, but none of you have given me the answer for this. Why is it so? You guys have forgot or you could not able to do this? Hmm? Yesterday I gave this as a homework, right? I did not get even a single answer from you guys. Why is it so? All of you can able to understand the rules of IUPAC, right? Yes or no? Do you guys have any doubt in solving the problem? JNV Shimoga wants me to show the slide of this. Okay. Um, JNV Shimoga students, what you do, you go to the YouTube live page. Okay, so there you can find the yesterday's session and you can listen that lecture and you can get the rules there. Okay, because it has many slides. All the rules are not given in the same single slide. So if I show you, it will take some time. So you can go to the Avanti Live 2 channel and get the video or the recorded session of yesterday's class. Is that okay? I think yesterday you did not join for the class, right? JNV Shimoga. Did you guys join yesterday? I think no. Yeah, so you go to Avanti Live 2. So let me share the name of the channel. Okay, it is Avanti Live 2. So if you guys give me a minute. Yeah. So if you guys go to this channel, you can get the recorded session. Okay. So go through the lecture and learn how to find out the IUPAC name of each compound. Okay. So from rule number 1 to rule number 5. Got it? Okay, fine. Whether you have forgot to do the homework or you did not concept, I don't know. Okay, if you did not understand or if you want me to explain your doubts, you can bring those doubts to the class. Okay, so we can discuss and get the clarity, better clarity. So please don't avoid the homework like this. Okay, so don't skip the homework. Please try to do what we are giving. Yes, it is for your goodness only. All right. So now let's go for the next topic. So far we have discussed about the nomenclature of compounds which has functional groups. And all the compounds that we have discussed so far are the aliphatic compounds. Okay. So now next we are to the nomenclature of aromatic compounds. Nomenclature of aromatic, mainly the substituted benzene compounds. Nomenclature of substituted benzene compounds. Okay. Now the substituent is placed as prefix to the word benzene. So this is the rule which you are going to follow to name the aromatic compounds. Okay, substituent. So if I am having CH3 as a substituent in the benzene, then what I have to do, I have to keep that CH3, which is called as methyl, as a prefix to the word benzene. You see here, the compound name is methyl benzene. Okay. The name of the compound is methyl benzene or toluene. Toluene is the other name for this compound. So here we have only one substituent. So the class of compound is coming under monosubstituted monosubstituted benzene compounds. Okay. So instead of CH3, if I have OCH3, OCH3 means alkoxy. This is called as alkoxy. And since we have only one carbon here, it is methoxy. If I have two carbon, it is ethoxy. Okay. So it is called as methoxybenzene. So methoxy is the prefix and benzene. The other name is anisole. The other name is anisole. Then, if NH2 is attached, NH2 means it is amino group. So, it is aminobenzene or aniline Okay. Then, if I have CHO, this is called as benzaldehyde. Okay, here we don't have the prefix because it is a main functional group. So, all these are substituent kind of thing. But CHO is the important functional group which will come in the first few priority order. Okay, so it is called as benzaldehyde. All right. Then if I have NO2, NO2 is called as nitro group, right? So it is nitrobenzene. And if bromine is attached, it is bromobenzene. And COOH. COOH is the first member. Okay, comes in the list. So it is called as benzoic acid. It is called as benzoic acid, and if OH is attached, it is called as phenol. Okay. So all these 8 compounds are very, very important. Okay. So we are doing the first lesson of organic chemistry. So the next lesson will be hydrocarbons. The hydrocarbon lesson, you will study about this methylbenzene, toluene, etc. And if you go for class 12, there you will start with the haloalkanes and haloarenes. So in that lesson, we will discuss about this bromobenzene, etc. Okay, chlorobenzene, bromobenzene. And the next lesson is alcohols, phenols. So in that, phenol will be discussed. And after that, we have ether. So in the ether part, the anisole will be discussed. Okay, after that, we have aldehyde. So in that, benzaldehyde will come. And in carboxylic acid, we'll study about benzoic acid. And then amines lesson, we will discuss about aminobenzene, etc. Okay. So this nitrobenzene will be the part of this amines lesson. Got it? So all these 8 compounds, the monosubstituted benzene compounds are very, very, very important. Okay, so you should learn the names now itself. You should learn the names now itself. Okay, please try to learn the names. The other 2 names I have given for few compounds, right? So you have to go for those names also. You have to learn the other name. For methylbenzene, it is toluene. For methoxybenzene, it is anisole. And for aminobenzene, it is aniline, right? So the other name is also very important. So try to memorize the names of these monosubstituted benzene compounds today itself. Will you all do that? Will you all study the name of these compounds today itself? Yes? Will you all study, students? Yes. Okay. Very good. So let me go for the next. Let me go for the di-substituted compound. So far, we had only one substituent, right? So now let me go for the di-substituted compound. So here in this benzene ring, I have 2 substituents. Okay. The 2 bromo I'm having. 2 bromo. So let me number. Let me number like this in a clockwise manner. So we have 2 bromo. Okay. So the lowest number has to be given for the substituent attached carbon. Okay, lowest number has to be given for the substituent attached to carbon. That's why we are numbering this in a clockwise manner. If you are going according to anti-clockwise manner, what will you get? If I start with 1 here, 1, 2, 3, 4, 5, 6. So I will get 1 and 5. So 1 plus 5 is 6. But 1 plus 3 is 4. So you should get the lowest possible number. Okay, so that is what the locant rule says. So we are following that rule and we are numbering the compound like this in a clockwise manner. Okay. So 1 plus 3 is equal to 4. So which is the lowest number? And the name of the compound is coming out to be 1, 3 dibromobenzene. 1, 3 dibromobenzene. Okay. So this is the correct IUPAC nomenclature of this compound. Clear? So if I go in anti-clockwise manner, as I have already told you, 1 plus 5, which is coming out to be 6. So 1, 5 dibromobenzene is the incorrect answer. That is not correct. All right. Clear for all of you? Can you understand? Shall I go for the next? Praveen, Suhra, Shirley. Yes? Okay, okay, Pragati. Okay. So now let's go for some more information about this substituted benzene compounds. In trivial system of nomenclature, what is meant by trivial system? In the common name. So there are two different types of names, right? Common name and IUPAC name. So in the common naming of nomenclature, the terms ortho, meta and para are used. Okay? Ortho, meta and para are used. So what is meant by ortho? If two substituents are adjacent to each other, here you see the two bromo are adjacent to each other. If they are adjacent to each other, then they are called as ortho compound. Okay. The IUPAC nomenclature will be 1, 2 dibromobenzene, but the common name of this compound is ortho dibromobenzene. Okay. The term ortho, meta, para is used in the common naming. And in the IUPAC naming, we use numbers. Okay. So the first is the IUPAC nomenclature. And the second row is giving the common name of the compound. Okay. Now, if two substituents are alternative to each other, alternative, okay, if two substituents are placed alternative to each other, then it is called as meta-dibromobenzene. It is called as meta-dibromobenzene and IUPAC naming is 1, 3 dibromobenzene. Okay. Now, if they are opposite to each other, if they are opposite to each other, then the IUPAC naming will be 1, 4 dibromobenzene and the common name is para-dibromobenzene. Is it clear to all of you? So what is meant by ortho? Ortho means adjacent. Okay. Meta means alternative. Para means opposite. Okay. Clear? No one should forget this compounds rules till the end. Okay, no one should have any confusion here. Adjacent ortho, alternative meta, opposite para. So please note down all these things in your notebook and study everything today itself. So any doubt from this for anyone? Everything is clear? Fine. So shall I go for the next slide? If you want me to stop anywhere or if you want some time to write anything, you can ask me to stop. I will wait for you. Shall I go for the next slide? Okay, what about others? Okay, fine. Okay, Nandini. So now, in some cases, the common name of benzene derivatives is taken as the base of the compound. Okay, it is taken as the base of the compound. So now let us go and discuss some tri-substituted benzene compounds. Okay, let us discuss how will we know the position of this 1, 2. Ortho dibromo means, Pragati, it is adjacent. You cannot number it as 1, 6, right? How will you number it as 1, 6? Just now I have told that we have to follow locant rule. So according to the locant rule, the substituent attached carbon should get the lowest number. right? Substituent attached to carbon should get the lowest number. So if you are drawing the molecule like this, if you are drawing the molecule like this, my dear, so if you are drawing the 2-bromo like this, then what you have to do, you have to number in the anti-clockwise manner. So 1, 2, 3, 4, 5, 6 like this. Are you getting my point? Only after seeing the compound, we are numbering it, right? So if the compound is given to you like this, then you have to start numbering according to the anti-clockwise manner. Clear? Is it clear? Okay. So it is not that we have to number all the benzene ring in a clockwise manner. Okay, if some compounds are given in the other way around, we have to use the anti-clockwise manner. Okay, there is no rule that we have to follow the anti-clockwise manner only. Clear? The anti-clockwise numbering is also possible. It is according to the compounds. Okay, fine. So now let's go. Very good question you have asked. So now this is the tri-substituted benzene compound. Tri means 3 substitutions are there in this benzene. So what is the name of this compound? So here you see the numbering is done from chlorine. So if you start from chlorine only, you will get the lowest possible number. So chlorine has 1 and nitro has 2 and the other nitro has 4. So 1 plus 2 plus 4 is 7. So if you start numbering from nitro 1, 2, 3, 4, 5, 6 and all, you will end up with the biggest number value. Okay. So the numbering which is given here on the slide is the correct way of numbering, and this only will give you the lowest possible number. Okay, you can check with other numbering also. You can start from nitro and go in anti-clockwise manner. You can start from the second nitro and you can go in clockwise or anti-clockwise. Everything will give you the answer in the highest number value only. Okay, so only this is the lowest possible number giving system of numbering. Okay, so now what we have to do? We have to go for the substituents. So this is chloro and these two compounds are called as nitro. Okay, so chloro, nitro. Mostly both of them are substituents only. Okay, so now what we have to do? We have to follow the alphabetical order. So which comes first in the alphabet? C, right? So it is 1 chloro, 2, 4 dinitro benzene. 1 chloro, 2, 4 dinitro benzene. Is it clear to all of you? Any doubt? 1 chloro, 2, 4 dinitrobenzene. I'm just following the alphabetical order. That's all. After numbering, go for alphabetical order and start naming the compound. Shall we go for the second compound, students? Okay. So take this. So here, only if we start with CH3, we will end up with the smallest number, lowest possible number. So that's why the numbering is done like this. Can you tell me the name of this compound? Can you tell me the name of this compound? So NO2 is nitro. Cl is chloro. Okay. And CH3 is methyl. CH3 is methyl. What is the name of this compound? The benzene ring attached with CH3 has one more name also, which is called as toluene. Okay. Or it is called as methyl benzene. Just now we have discussed, right? The two names for some compounds. So toluene or methyl benzene. Keep this in mind and start naming the compound. Start naming the compound. What could be the correct name of this compound? Let me see. Has anyone got the answer? Go according to the alphabetical order, students. What is the name? Numbering is there. And also I have said that you have go according to the alphabetical order. What is the correct name of this compound? Very easy, right? Try, just give a try. Don't think that you will give the wrong answer. Don't think of that or whether it is right or wrong. Give a try. Don't feel scared. 2-chloro, 1-methyl. So that is one small mistake in Pragati's answer. You are mentioning toluene. Then why 1-methyl? So methyl will come in the toluene part itself, right? So Praveen is saying it is 2-chloro, 1-methyl nitrobenzene. 4-nitrobenzene. Okay. Okay. Listen. The correct name of this compound is 2-chloro-4-nitro-toluene. So what I have done is I have taken that methyl part as a I have taken that methyl part along with the benzene ring and I'm calling that as toluene. Okay. So I'm taking this entire thing as toluene. This is toluene, right? So I'm not giving the number for methyl. I'm not giving the number for methyl. So if you are bringing any substituent into the phenyl ring, then you should not mention that number. Okay, you should not mention that number. So mostly the one which is attached as a substituent to carbon number 1 will be taken like this. Okay, so since in carbon number 1 I have methyl group, I am taking this as toluene. Okay, Praveen, can you understand? Can you understand? Mostly the substituent which is attached to carbon number 1 will be taken as the parent chain kind of. So we have done in the aliphatic compounds, right? So we have to take the carbon number 1 position containing substituent into the parent chain and we have to do the problem accordingly. Got it? You can go for 2-chloro-4-nitro-methylbenzene also. 2-chloro-4-nitro-methylbenzene. 2-chloro-4-nitro-methylbenzene. Clear for all of you? Yeah. So this is how we have to give the name for the substituted benzene compounds. Okay. So here we are ending up with the nomenclature part of this lesson. Got it? So when you go for each and every lesson, we will discuss about the nomenclature of that particular compounds which we are going to study in that lesson. Okay. Clear? So 2-chloro, 1-methyl nitrobenzene. So that's why, my dear Pragati, you have to bring the substituent which is attached to carbon number 1 into your parent chain. Parent chain means to the benzene, substituent as a benzene. Clear? So if I am having a compound like this, listen, let me clear your doubt. If I am having a compound like this, NO2, Cl and CH3. Listen, if this is my compound, how will I number? I will start from nitro, right? 1, 2, 3, 4. Because then only the locant rule will be satisfied. What is meant by locant rule? The substituent attached carbon should get the lowest possible number. Okay. So 1, 2 and 4. 1 plus 2 plus 4. I'm ending up with 7. Got it? So if I start from methyl, 1, 2, 3 and 4 like this. So just add the numbers of the substituents. I'm having 1, 3 and 4, right? So it is 1 plus 3 plus 4. So what is the answer? It is 8. It is wrong. So I should not follow the anti-clockwise numbering. So let me erase it. Let me erase it. Okay. Anti-clockwise numbering is incorrect. Anti-clockwise numbering is incorrect. So this is the correct way of numbering. So now I have to start. So the substituent which is attached to this carbon number 1 can be taken as a parent chain. I think you are getting my point. So Cl is chloro and CH3 is methyl. So you can follow the alphabetical order. So it is 2-chloro, 4-methyl nitrobenzene. 2-chloro, 4-methyl nitrobenzene. Is that okay? 2-chloro, 4-methyl nitrobenzene. Is it clear to all of you right now? Yes. Fine. Any other doubts? Do you guys have any other doubts from the nomenclature of substituted benzene compounds or from the nomenclature which we have discussed in yesterday's and before that? Everything is clear? All right. So now the next topic is isomerism in organic compounds. Okay? Isomerism in organic compounds. So the learning objectives under this topic are, we are going to discuss about the isomerism, the definition of isomerism and the two types of isomerism, which are structural and stereoisomerism. Okay. So let us enter into what is isomerism first of all. So isomerism is the phenomenon of existence of two or more compounds possessing the same molecular formula but different properties. Okay, what is isomerism? Two or more compounds. Mostly we will discuss about two compounds. Okay, mostly. So two or more compounds possessing same molecular formula but different properties is called as isomerism. You all know iso means same. Iso means same. So who is going to be same? Molecular formula is going to be same. Okay, but different properties, different chemical properties and different physical properties will be there. So those compounds are called as isomers and the phenomenon is called as isomerism. Okay. Now isomerism is classified into two. One is structural isomerism and the other one is stereoisomerism. Okay. So structural isomerism is further classified into four. The very first is chain isomerism. The second classification is position isomerism. Third classification is functional group isomerism. Fourth classification is metamerism. Chain, position, functional group, metamer. Okay. Now the stereoisomerism. Stereoisomerism is classified into two. One is geometrical isomerism and the other one is optical isomerism. So these are the classifications of isomerism. Okay. So this is a flow chart which shows the classification of isomerism. So we are going to do one by one. So shall I start with the structural isomerism? So let us discuss the definition of structural isomerism and then we will discuss each and every type under this. So shall I go for the next slide, students? Shall I go for the next slide? Do you want to take down anything from this? Okay, Nandini, what about others? Ajmala, Anjum, Farnas. Shall we go for structural isomerism? Okay. Okay, Praveen. What is structural isomerism? Compounds having same molecular formula but different structures are called as structural isomerism. Very easy, right? From the name itself, it is understood. Same molecular formula but different structure. That's all. So the first classification under structural isomerism is chain isomerism. What is chain isomer? When two or more compounds have similar molecular formula but different carbon skeleton. So chain isomerism means the molecular formula will be same, but the carbon skeleton will be different. So what is the meaning of carbon skeleton? I will take one example and I will explain. So the formula is, the example that I have taken is C5H12. C5H12. Okay. So this is the compound which we are going to take as an example to understand this chain isomerism. So three different types of compounds can be written using this formula. So the first one is pentane. So in pentane, you see we have 5 carbon and 12 hydrogen. And the second compound is isopentane. Here also we have 5 carbon and 12 hydrogen. But in isopentane, we have one branch. Okay, CH3 is a branch. And in this third compound, you see, we have 5 carbons and 12 hydrogen, but there are 2 branches. There are 2 branches. So let me give you the other name for these compounds. For pentane, it is pentane only. The IUPAC name for isopentane is 2-methyl-butane. It is 1, 2, 3, 4, right? So it is 2-methyl-butane. And the IUPAC name for neopentane is 2,2-dimethylpropane. This is the parent chain. And to the second carbon, 2 methyl groups are attached. So it is 2,2-dimethylpropane. So these are the IUPAC names. So the carbon skeleton is different for all these three. Even though all these three compounds have same formula, the carbon skeleton for pentane is in a straight chain manner like this. And for 2-methyl-butane, it is like this. And for 2,2-dimethylpropane, it is like this. Carbon skeleton is different, right? So these are the compounds which is falling under this particular example, coming under the chain isomerism. Can you all able to understand? Can you all understand what is meant by different carbon skeleton? So three compounds are having same molecular formula, but different carbon skeleton. They are called as chain isomers. Shall we go for the second type? Okay. The second type of isomerism is called as positional isomerism. So what is this? When two or more compounds differ in the position of the substituent or functional group on the carbon skeleton. Let us take one example. C3H8O. For C3H8O, propan 1-ol is one example and propan 2-ol is another example. So in both the compounds, if you look into the compounds properly, we have 3 carbons, 8 hydrogens and 1 oxygen in both. But why one is called as propan 1-ol? Because OH is attached to carbon number 1. And here OH to carbon number 2. So the position of the functional group to which it is attached is different. So here it is attached to carbon number 1 and here it is attached to carbon number 2. Okay. So that's why this is falling under positional isomerism. Okay. So isomerism always exists in pairs. Pairs means at least 2 compounds will be there. Okay. In the previous case, we had 3 compounds. Minimum 2 compounds will be there. Got it? So propan 1-ol and propan 2-ol is the example for positional isomerism. It means the position of the functional group to which it is attached to the carbon will be different. One more example. C3H9N. Propan amine, propan 2-amine. So here NH2 is the amino part. So NH2 is attached with carbon number 1 here and it is attached with carbon number 2. So propan 1-amine, propan 2-amine. Position of the functional group differs. Clear? Is it clear to all of you? Can you able to differentiate between the chain isomerism and the positional isomerism? Or do you guys have any doubt? If it is clear, please give me your response in the chat box. Okay. Thank you so much, Farnas. What about others? Great. Now let us enter into the third type of isomerism, which is called as functional isomerism. What is functional isomerism? Two or more compounds having the same molecular formula but different functional group. So functional group itself will differ for the two compounds which we are going to take. Okay. So listen carefully. So we are taking C3H6O as an example. For this formula, I can draw propanone as one example, where ketone is the functional group, and propanal as the other example, where aldehyde is the functional group. So the formula is same for both, but the functional group itself is differing. So in the positional isomerism, we have seen that functional group remains same. So in the first example, if you remember, both the compounds had the alcohol as the functional group, and the second example had amino group as the functional group, right? But here, the functional group itself is differing for the isomers, but the formula remains same. Clear? So those will come under the functional isomerism category. Is it clear to all of you? So C3H6O, but the functional group is different. So like this, we have different set of functional isomerism, or you can say we are having different types of set of isomerism, functional isomerism. Let me give you those types also. The first type is, or the first pair is alcohol with ether. So alcohols always pairs with ether. What is the formula for alcohol? ROH. And what is the formula for ether? ROR. Okay, alcohol always pairs with ether. Then the second pair is aldehyde and ketone. That's just now we have seen, right? RCHO is aldehyde and RC double bond OR is ketone. And the third pair is cyanide and isocyanide. Cyanide means RCN, isocyanide means RNC. Okay, so these two are the pairs. And fourth one, acid and ester, carboxylic acid. Okay, acid means carboxylic acid. So what is the formula for carboxylic acid? RC double bond OOH, and ester is RC double bond OOR. Okay, so from where I am writing all these formulas? Yesterday we have discussed, right? The functional groups, the formula, the prefix and the suffix. So please go through that. You will get the formulas in that slide. And the fifth pair is alkene and cycloalkene. So you all know what is alkene, right? The double bonded carbon system. So let me take an alkene. Let me take propene. So propene means it is CH3, CH double bond CH2. And cycloalkane means the 3 carbon containing cycloalkane is cyclopropane. So these are the 5 pairs of functional isomerism. Okay. So if some formula is given to you in the question, and if you are searching for the correct pair of functional isomerism in the options given to you, then you can recall these types or the pairs. Okay. So if you are ending up with an aldehyde, don't check for ether, because aldehyde always pairs with ketone. So you have to try to get the structure of ketone. Okay. So if alcohol is given to you, means what alcohol? Let me take one example. C4H9 H10O. If this is the compound formula, then it is a formula for alcohol, because it is CH3, CH2, CH2, CH2 and OH. Check here, we have 4 carbons, right? 4 carbon and 10 hydrogen and 1 oxygen we have. If you are getting alcohol as one of the compound, then immediately you have to try to draw the structure of ether. Ether means CH3, CH2, O, CH2, CH3. So this is ether, right? This is ether. You just check the number of carbons and hydrogens. We have 4 carbon and 10 hydrogen, right? So alcohol always pairs with ether. If you try to draw the structure of aldehyde or ketone, you will not end up with the formula, correct formula. So let me try with 4 carbon containing aldehyde, you see. So CH3, CH2, CH2, CHO. So this is a 4 carbon containing aldehyde, right? So we have 4 carbon. But how many hydrogen we have? 5, 6, 7, 8. 4 carbon, 8 hydrogen and only 1 oxygen. So you see, we have 10 hydrogen. So if you try to draw the structure of aldehyde or ketone which has 4 carbons, then the formula will not be satisfied. Okay. So without making any confusion or without going to the confused state, you better memorize the types or the pairs which I am giving you here in this slide, so that it will be easy for you to find out the second isomer from the first. Is it clear? I will discuss one example under each type. Don't worry. Is it clear up to this? Alcohol ether, aldehyde ketone, cyanide isocyanide, acid ester, alkene and cycloalkane. So just memorize these 5 types and understand. Shall we go for the first type? Shall I give you one example for the first type? Do you guys have any doubt? Students, tell me, shall we go for the first type? Alcohol and ether. Let us discuss example under each type. Am I audible? Yeah. Listen. So the first type is alcohol and yeah. Yes. The first type is alcohol and ether. Okay, you can follow this general formula. Okay, you can follow this general formula or you need not follow this. It is up to you only. Alcohols and ethers will fall under this general formula. So alcohol means ROH and ether is ROR. This we have already studied. Example, C2H6O. C2H6O means it is 2 carbon containing alcohol. 2 carbon containing alcohol is called as ethanol and the 2 carbon containing ether will be the pair. Okay. Ethanol. This is ethanol. And what is this? This is methoxymethane. Methoxymethane, where we have 2 carbon and 6 hydrogen and 1 oxygen. Okay, so this is alcohol and ether example. The second type is aldehyde and ketone. The general formula will be CnH2NO. Aldehyde formula is RCHO and ketone is RCOR. Ketone. Example, C3H6O. 3 carbon containing aldehyde. So it should be CH3, CH2, CHO. And for ketone, it is CH3, CO, CH3. Okay. So 3 carbon and 6 hydrogen and 1 oxygen is present. Alright. Now the third pair is cyanide and isocyanide. Cyanide means RCN. Okay. So let me take the R group as CH3. If the R group is CH3, I will get CH3CN. And for isocyanide, it is CH3NC. CH3NC. So cyanide and isocyanide. So we have 2 carbons in both the cases and 3 hydrogens in both the compounds and 1 nitrogen in both the compounds. C2H3N is the formula for both the compounds. Okay. So this is the third pair. Fourth pair is very important, which is acid and ester. The general formula for acid and ester is CnH2nO2. Formula for acid is COOH and for ester it is COOR. This is acid and this is your ester. The example is C3H6O2. 3 carbon containing carboxylic acid. So it should be CH3, CH2, COOH. Right? CH3, CH2, COOH. 3 carbon. And 6 hydrogens are there. And we have 2 oxygen. Okay. And what could be the formula for ester? So ester should be CH3COOCH3. CH3COOCH3. So we have 3 carbon, 6 hydrogen and 2 oxygen. So only acid and ester pair will have 2 oxygens. All other compounds, aldehyde, ketone, alcohol, ether, all those other 4 compounds will have only 1 oxygen. Okay, the 2 oxygen containing compounds are acid and ester. Okay, this is the fourth pair. Then the fifth one is alkene and cycloalkane. So this is a general formula for alkene and cycloalkane. CnH2n example is C3H6. I already gave you, right? Propene and cyclopropane. If you check the number of carbons and hydrogen, it will be same. 3 carbons and 6 hydrogens will be present in both the cases. Okay. So this is about the functional isomerism. Got it? This is about the functional group isomerism. So there is one more isomerism under structural isomerism, which is called as metamerism. So let me cover that and then wrap it up the today's session. Okay. So what is meant by metamerism? So it arises due to different number of carbon atoms on either side of the functional group. Let me take one example, C4H10O. So you see here, these two compounds are the metamers of each other. Both of them have same molecular formula, but the number of carbon atoms on either side of the functional group is different. So what is a functional group? Ether. R, O, R is the functional group. So in the first compound, I have only one carbon in the left side. In the second alkyl part, I have 3 carbons. Here, 2 carbon, and in the right hand side also 2 carbon. So the number of carbon atoms on either side of the functional group or the heteroatom in the molecule is different. Okay, so generally I can write like this. R, functional group R. Example, ether. ROR. Minimum 4 carbons are required to draw the metamer for ether. So in this compound also we are having 4, right? So minimum 4 carbon is required to draw the metamers. Got it? Then you can go for amines. Amines will have RNHR. So NH is the functional group and the 2 alkyl groups which are attached should have different carbons. And thioether. Instead of oxygen, if you put sulfur, it is called as thioether. The remaining things are same. And ketone. RCOR. RCOR. So to write a ketone, the metamer of ketone, you should need at least 5 carbons to draw the metamer. Okay. So the number of carbon atoms attached to either side of the functional group will be different. So those are called as metamers. Okay. So this is all about metamerism, students. So with this, the structural isomerism part is getting over, and in tomorrow's session, we will discuss about the stereoisomerism part. Okay. So do you guys have any doubt from today's isomerism part and in the nomenclature of substituted benzene compounds part? Do you guys have any doubt? No doubt? Is everything clear and okay? Yes or no? Okay then. Thank you so much for listening to today's lecture, students. See you all the next class. Bye-bye. Get ready for your next class. Thank you.